Let f of x equal x to the fourth minus 128x squared all over 3, and use the derivative rules to find f prime of x. Well, the derivative here, I'll just pull the 1/3 to the side and use the power rule on the resulting polynomial. So that would be 4x to the third minus 256x. And the second derivative, I still have the 1/3 out here, and it would have a derivative of 12x squared minus 256. All right, so there's our first and second derivative. The intervals of increase and decrease. Intervals of increase occur whenever the first derivative is greater than 0. Intervals of decrease occur when the first derivative is less than 0. So essentially we need to find out where the derivative is 0 and then test intervals around that value. So it's good to have a number line to organize things. And I'm going to take the first derivative, set that to 0, and solve. Okay, so I'll leave the 1/3 in, just out of habit. But inside these parentheses, I'm just changing to a bracket just for I can distinguish it from the parentheses. I have a common factor of 4x, which I can pull out, and that would leave me x squared minus 64, it looks like. Okay, and then that leaves me, actually I can get rid of these brackets now and just say this is 4/3 times x times, this is the difference of squares, so it would be x minus 8 times x plus 8. So I have zeros at 0 itself, positive 8, and negative 8. All right, now putting those on a number line. That's great. And let's see. So what I will do is pick some test values in order to determine which of these intervals the derivative is positive or which one's negative. So essentially I just need to pick a number within each interval, and I generally go for the smallest number I can, and I don't know why I made that a negative 8, sorry about that. Oh, I probably was just reading this one. Anyway, I need them in increasing order, so it should be negative 8, 0, and positive 8. Okay, then next up, I'm going to take these values, plug them into the derivative, and see if I get something that's positive or negative. So if I put negative in here, so a negative 9, the 4/3 doesn't matter because it's positive. It's not going to change the sign on anything. So I have negative 9, because that's where the x, for the x. Negative 9 minus 8 is negative 17. And negative 9 plus 8 is negative 1. So 3 negatives multiplied together to give me a negative value overall. All right, negative 1, I would have negative 1 times negative 1 minus 8 is negative 9. Negative 1 plus 8 would be 7. So that would result in a positive value. And if you have a bunch of these, feel free to use the calculator and the list feature to help speed things up. Here, if I plug in 1, that would be 1 times negative 7 times 9, and that is a negative result. And if I plug in 9, this would be 9 times 1 times 17, and that results in something positive. Okay, so let's see here. I am increasing whenever the first derivative is greater than 0. So on this interval here, from negative 8 to 0, and then again from 8 up to positive infinity. So there we are increasing. We are decreasing whenever the first derivative is less than 0. So here from negative infinity to negative 8, and then again from 0 to 8. What intervals is f concave downward? So for concavity, we look to the second derivative, and we're concave down whenever the second derivative is less than 0, and concave up whenever the second derivative is greater than 0. So we essentially just have to do the same thing that we did with the first derivative. We just have to find the zeros of the second derivative and check intervals where the second derivative is larger than 0 or smaller than 0. So let's see, we had 1/3 times 12x squared minus 256. Double check that. Okay. So looking for zeros here, one thing that I do notice is that there's a common factor of 4 here I can pull out. So tell you what, let me do this. I'll write it as 4/3 times, that would leave me 3x squared minus 64. And this isn't exactly the difference of squares. It can work like this difference of squares, but if you're more comfortable just taking that factor itself and setting it to 0 and solving, that's perfectly appropriate here. So I would have 3x squared equals 64, or x squared equals 64/3, so that x equals the plus or minus square root of 64/3, which can reduce to the plus or minus 8 over root 3. And that's because when you take the square root of a fraction, you can take the square root of the numerator and denominator separately. So the square root of 64 is 8, and then the square root of 3 is just 3. Square root of 3 because it's not a perfect square. And it's perfectly okay in calculus to leave a denominator with a radical. That's no problem at all. You can rationalize if you like, but there's really no need. So let's see. We have a 0 at -8 over root 3 and at +8 over root 3. And what we need are some test values. But I don't know what this number is in order to pick a test value. So let's see. If I take 8 divided by the square root of 3, that gives me 4.61. So I could choose, say, -5 as a test value because that's smaller than -4.61. 0 is clearly on this interval, and +5 over here would work just fine. Now, I need to take these values, plug them into the second derivative, and I'll just plug them in here. That would be fine. And you know what? Maybe I'll use the calculator to help speed things up this time. Effectively, if I just take my function, put that in for y1, and use a table, then I can evaluate at a bunch of different values quickly. So let me clear some of these things out. All right, so at -5, at 0, and +5. So it's positive, negative, positive. All right, so my function is concave downward whenever the second derivative is negative. So that's on the interval from -8 over the square root of 3 to +8 over the square root of 3. And concave up wherever the second derivative is positive. So that's on the interval from -infinity to -8 over root 3. And then again from +8 over root 3 up to +infinity.